In example 2, we will be determining total cost. A developer prices condominiums in Florida at $20,000 plus $40 per square foot of living area. The first thing we want to do is express the cost C as a function of the number of square feet of living area S. In step 2, we'll find the price of a 1,600 square foot condominium, and then we'll use that information to help us graph the linear function. So if we look back at the scenario, it says that a developer prices condominiums in Florida at $20,000 plus $40 per square foot. So plus will translate as the plus sign. $20,000 is a fixed amount, and $40 per square foot is where the price is varying depending on the square footage. So $40 per square foot means it's $40 multiplied by S. S is the variable given to represent the square footage. So our total cost must be made up of these two pieces, the fixed amount of $20,000 and then the additional charge of $40 per square foot. So when it comes to writing our equation, we always want to be thinking about y equals mx plus b if it is a linear function. And we do have that linear function. So instead of y, we're using c to represent the total cost, m, or slope, multiplied by x, that's our 40s term. So 40s, and our plus b is the 20,000. So if we write this with function notation, cost is a function of the square footage. Now this will help us to answer question 2. Find the price of a 1,600 square foot condominium. Since 1,600 represents the square footage, we know that S is worth 1,600, so we can make that substitution. We're actually looking for the cost of a 1,600 square foot condominium. So we need to take 40 multiplied by the 1,600, and then we'll be adding the 20,000. So C of 1,600 would equal 40 multiplied by 1,600, and that's going to be 64,000, added to the 20,000 flat fee. So we can see that C of 1,600 now is equal to that sum of $8,400. So we really just generated the ordered pair, 1,600, 84,000. Now, since that's only one ordered pair, it's not enough information to see what this linear function looks like. So it would be helpful maybe to find the y-intercept. So in order to find the y-intercept, we're going to let x equal 0. So in this case, x is really S for square footage. So C of 0 would be equal to 40 times 0 plus the 20,000. And that is 20,000. Because we can see 40 times 0 would be eliminated. The ordered pair we just found then would be input of 0, output 20,000. So these are the two ordered pairs we're going to plot. Going to the graph, input, we used to call this the x-axis, we're now calling that S, which represents our square footage. Again, we're always starting with 0. And our other axis is the total cost, which is C of S. And this, of course, is in dollars. So what we need to be sure of is that we're using a scale that will accommodate these numbers. X values are 0 and 1600. So along the square footage axis, we need to accommodate a number as large as 1600. So if we count by 200s, that should fit. So if the first line is worth 200 and I keep counting by 200s, that will be helpful. Along the cost axis, our largest value there, we're comparing 20,000 with 84,000, so 84,000 would be the largest. We'll need to count probably by 5,000 for each line. So the next line would be 10,000. So it looks like if I skip every 2 lines, I'll be counting by 10,000s. So I can plot my 2 ordered pairs, 0, 20,000, and the other ordered pair at 1600. I'll need to go up to 84,000, so about right there. Now I'll draw my line. I'm starting off with just going from one dot to the other dot, but we need to ask if the ends should be arrows or dots. So would it make any sense for this scenario to continue to the right? That means square footage increases and total cost increases. So that sounds possible. So this function could continue with an arrow in this direction. At the other end of the line, if I continued going down, that would represent square footage smaller than 0. That would be negative square footage. That's not possible. So this graph is complete with a dot at this end, but an arrow in the other end. And the last item that you may want to include here for your graph is a title, and that comes from how you've titled your axes. So total cost by square footage. So now we have a complete graph. The last item we would want to think about is the domain and range that are associated with our graph. The domain would be the input values. That's our square footage. The smallest square footage would be 0. So you don't even have the condo yet. And as we follow our line going left to right, the square footage increases, and since there's an arrow, we've put no limit on this. So from 0 to infinity for domain, and the range, those are the output values. That's total cost. So the smallest cost is the 20,000. And going up, again, we have an arrow, so there's no limit to how much one could spend on these condominiums. So 20,000 to infinity would be the range. I hope you found this video helpful.